In this class, I'm going to discuss one important diode circuit. So that is Clipper circuit. So Clipper circuit is a circuit that is used to remove some part of any particular waveform. Okay. For some specific application, we need to reshape a particular waveform, and that type of waveform cannot be directly generated using the function generators or the waveform generators. So what we can do, so we can reshape the available waveform such as sinusoidal wave or any other type of waveform which can be generated directly using function generator, and then we can reshape it as per the requirement. So the basic function of a Clipper circuit is to clip off the unwanted part. Okay. So we can use diode to design a Clipper circuit. Now, depending upon the position of a diode in the circuit, so there are two types of clipper. One is series clipper. So you can see the series clipper where the diode is connected in series. And second one is the parallel clipper or shunt clipper where the diode is connected in the parallel. Okay. So apart from that, so we can add extra bias voltage or battery. Okay, so that suppose I want to remove some part of output waveform of the waveform. Okay. So we can additionally use some additional bias voltage, okay, along with this diode and resistance in the Clipper circuit. So if suppose in this circuit, in the figure 1 and 2, so there is no such additional DC bias voltages. Okay. So only input is there and we are getting output. So this type of Clipper circuits are called unbiased. Okay. So they are unbiased clipper. But there is another one type of circuit. See here, we are using one extra DC voltage source, okay, let VV, which is connected in series with the diode. Okay, so this type of circuit is called as a biased clipper. So sometimes we need this additional voltage source, okay, to clip off or to remove some part, not the whole part of a particular waveform. We shall see it while discussing the circuit operation, so we can check why this bias voltage is required. So let us see how the Clipper circuit works. So here I am taking some example. Okay, let's start with a simple one. See, so this is a parallel Clipper. As I told you, the diode is connected in parallel. The example one, so it is a parallel Clipper circuit. And for the analysis, I assume that the diode is ideal. So ideal diode means when the diode is on, it is having zero forward resistance and zero cut-in voltage. So the voltage drop across diode will be zero and the diode having zero forward resistance. But you know that the diode, for all practical cases, the diode having some finite resistance and some voltage drop will take place across diode, which is approximately 0.7 volt for silicon diode. So if you consider this diode is a practical one, so when the diode is on, so the voltage drop across diode will be 0.7 volt. So if you consider the practical case, so you need to consider the 0.7 volt instead of taking 0. Okay. So just to simplify our analysis, just to get the concept of Clipper circuit here, we consider the diode is ideal in nature. Okay, so let us see. Now you are already familiar with that diode forward and reverse characteristics. Okay, so if I apply a sinusoidal waveform at the input, okay, so this is my Vin. So during positive cycle, the diode will be on. Okay, this diode will be in forward biased. And when the diode is forward biased, so I already mentioned that we assume it is ideal diode. So we can replace the diode by using a short circuit. See here, the diode is shorted. Okay, so if the diode is shorted, so the output voltage will be 0 because see, if the terminal A and B is shorted, the output will be 0. Okay, so V naught equal to 0 in this case, simply. So again, check for positive cycle, the diode is in forward bias. Okay, so this one will be shorted, so output will be 0. So in positive cycle, we are not getting any output. So if we draw the waveform, the output will be simply 0 here, like this. Now let us see what will happen in the negative cycle. Okay. So in negative cycle, that means for pi to 2 pi section, that means we are talking about this section. Okay. See, the diode will be reverse bias. Why the diode is reverse bias? See, because the P side of the diode connected to the negative potential. In the negative cycle, this will be minus, this is plus. So the diode will be off. And again, the diode off means we can consider the diode is open circuit. Here it is open circuit. Okay. So the circuit current will be 0. No current is flowing through the circuit. So circuit current will be 0. Then simply V naught will be equal to V in. Okay. So you can easily analyze it by applying KVL. Suppose if we apply KVL in the circuit, so V in minus this IR drop minus V naught will be 0. Since current I is 0, the circuit is open. The circuit is not completed. So simply V naught will be equal to V in. That means for negative cycle, output will follow the input. Output will follow the input. So if we draw the sketch for negative cycle pi to 2 pi section, the output will be just like your input signal. So this is your V naught and this is your V in. So this one is your input. So this one is the output waveform. So this is the operation of a clipper circuit. So why we are saying it is a clipper? See, we are applying the full cycle. At the output, we are getting only one cycle. Okay. So this positive cycle, entire positive cycle is removed. Okay, the entire positive cycle is eliminated from the output. We are getting only the negative cycle. So we can say it is a positive clipper. Okay, so this one is a positive clipper because it clips, it removes the positive cycle. And of course, you can say it is one type of half wave rectifier because the output you are getting only one half cycle. So we can say that half wave rectifier is also one type of clipper circuit. A very simple example of clipper circuit is half wave rectifier. Now coming to the next example. Okay, so here we just change the polarity of a diode. So the things will be just opposite. So the diode will be on for positive cycle, and the diode will be off for positive cycle. So for positive cycle, diode will be reverse biased, and hence it can be considered as open circuit. So V in will be equal to V naught. If the diode is open, so if this diode is open, okay, so output will be exactly equal to V. Okay. Similarly, for negative cycle, the diode will be forward bias, and you can replace the diode by short circuit, similar to our previous analysis. Okay. So in negative cycle, so what we can do, we can replace the diode by short circuit, the negative cycle. So V naught will be equal to V in. So for positive cycle, we are getting output V in equal to V naught. And for negative cycle, okay, it is sorted. So V naught will be 0. For negative cycle, V naught will be 0. So the output we are getting is just opposite. Okay. See here, the entire negative cycle is removed. The input negative cycle is here, but in output, we are not getting any negative cycle. So we can say it is a negative clipper. Okay, so this one is a negative clipper. It removed the entire negative cycle. Okay. Now, all these examples, that is example 1 and example 2, so that is unbiased clipper. We are not adding any external voltage, means the bias voltage. Now let's see here, example 3. It is one example of biased clipper. See, one additional voltage is connected, VV is connected, which is connected in series with the diode. So let us see what will happen. So during positive cycle, so this one will be plus, this is minus. Now we have a situation here. See, the diode will be forward bias if the voltage across diode, means the voltage you are applying here at this terminal, should be greater than VV. Okay, because see, the battery positive terminal connected to N side. Okay. For example, VV is 5 volt. So the N side connected to 5 volt. Okay, and so if the voltage at this point is greater than 5 volt, then only the diode will be on. Otherwise, the diode will be off. Okay, so we have two cases. So we can write when V in less than VB, when the input signal, see, it is a sinusoidal waveform we are applying. So it is a time varying signal. When the input signal voltage less than this battery voltage VB, of course, the diode will be off. Okay, because this point voltage is less than 5 volt, for example, the diode will be off. And if the diode off, of course, the section will be open. This part will be open. Okay, this entire branch will be open. And because no current is flowing, so simply V naught and V in, they are same here. Okay. And in the second case, when V in greater than VB, that means the voltage at this point greater than this bias voltage 5 volt, then of course the diode will be on. And if the diode is on, you can simply replace the diode by short circuit. We just remove the diode and connect it by using a wire, just short it. Then see the output we are getting, that is basically VB. Okay, the output means the voltage between this point and this point. So this is nothing but VB. Okay, so for positive cycle, we have two situations. One is V in less than VB, where we are getting output equal to input. And for V in greater than VB, the diode will be on and forward bias. So V0 will be this VB. Now coming to the negative cycle, that is pi to 2 pi section, this one. So just place the diode again here. So diode was connected like this. Now see for entire negative cycle, so this polarity will be minus and this one will get plus. Okay. See for entire negative cycle, the diode will be off because the N side is connected to the positive polarity of VV and P side connected to the negative potential. So for entire negative cycle, so diode will remain off. Okay, so it is reverse biased. So if the diode is off, you know the entire section is open. So this section is open. Okay, so output will be simply equal to input. V out will be same as V in. Now we can plot the graph. So this is our V in. Okay, the yellow line. This is the V in. And we draw the reference line, which is VB, let 5 volt. And let's draw the intersection point here. So for V in less than VB for this part, okay. So for this part, okay, so this is for V in less than VB. Okay, so the result we got V0 equal to V here. V0 equal to V in. So V in and V0 they are same. Okay, so V in and V0 they are same. It will follow the same graph. But for V in greater than VB, when the input signal will cross VB, that means for this part, we are talking about this section. Of this section, check. So V0 will be constant, that is equal to VB. So V0 will be constant, that is equal to VB. A straight line here up to that part. And again for this part, output will follow input like this. And for entire negative cycle, output will be input. V0 will be V in. So for entire negative cycle, V in and V0, they are same like this. Okay. Now see here one interesting thing. In this circuit, this particular part is removed. This particular part, this section. So this section is not present. This section is removed. See, that's why we are using the additional voltage, bias voltage. While using this circuit, that is simple Clipper circuit, you can remove entire positive cycle or entire negative cycle. But if you want to remove some part, not the whole part of a cycle, so then you have to use the bias Clipper. Okay, so this portion is removed. Okay, this particular part is removed, eliminated. Okay. So similarly, you can practice those circuits. Okay. So the operation will be the same. The output waveform you will get a difference. See here, only that the VV, the polarity of VV changes, and here the polarity of diode changes. So depending upon that, you will get a different type of waveform, so you can solve it. Now coming to the solution of that. Okay, later we have this one. So basically we are talking about this one, I think. Yes, this. So let us see how to solve it. Okay. So for positive cycle, for 0 to pi section, okay, so for positive cycle, so this one will be plus and this one will be minus. So for entire positive cycle, the diode will be on because see the N side of diode connected to some negative potential of VB. Okay, battery negative terminal. The P side, we are applying some positive voltage. Okay, so for entire positive cycle, so diode will be on. And when the diode is on, the output you will get. Okay, so that is nothing but VB. Because you know diode is on means it will be replaced by short circuit. So output you will get that is the same as VB. And VB, it is connected in the opposite, in the just reverse way. So it will be minus VB. That means if battery is 5 volts, so output will be minus 5. Okay. Now in the negative cycle, here, that means it will be minus and this one will be plus. Okay. So for negative cycle, see, we have two different cases. Okay. So when your input, this one, is greater than minus VB. So let this point is connected to minus 5 volt. if this point voltage greater than -5 volt, let -1 volt or -2 volt, of course the diode will be on because P side is at higher potential compared to N side. So diode is on, and as long as the diode is on, output will be -VB. Similar to this, as long as the diode is on, it will be shorted and V0 will be equal to -VB. Okay, but when the voltage here is just below -5 volt or -VB, the diode will be off. Let here the voltage is -6 volt. So the diode will be off. When the diode is off, the circuit, the entire circuit will be open. So you can just open this entire circuit. And when entire circuit is open, simply V0 will be same as Vin. Okay. So V0 and Vin, they are same. So for positive cycle, we have V0 equal to -VB. And for negative cycle, we have two situations. When the input voltage is greater than this, we have V0 equal to -VB, and when input voltage less than this one in the negative cycle, we will get V0 equal to Vin. Now we can plot the graph. So since VB, the polarity is reversed, so here we draw the VB in this direction in the negative side. Okay. So for entire positive cycle, as per our statement, see here analysis, entire positive cycle output is -VB. So output is -VB here. For entire positive cycle output, we are getting -VB. And even for this part, V0 equal to -VB, as long as Vin greater than -VB. So as long as your Vin greater than -VB, even for this part also, the output you will get -VB. And for this part, diode will be off. Check. Diode will be reverse bias off, and V0 will be Vin. So this part will continue here. V0 will be simply Vin like this. So this is the output. Okay. So we are getting some typical waveform here at the output. So we are getting some part of the negative side, and for rest of the part, the output is constant. So similarly, you can analyze this circuit. Okay, so here the diode polarity is just changed. You check. For positive cycle, this one will be plus and this one will get minus. Okay, and see here, for positive cycle, since the battery voltage positive side connected to P side of a diode, check here, the battery positive terminal connected to P side of a diode. Okay, so as long as this point voltage less than VB, as long as the N side voltage means this voltage Vin is less than VB, the diode will be on. So when Vin less than VB, the diode will be on. And when diode is on, it will be treated as short circuit. So V0 and VB, okay, it will be same. So output will be VB. And when this point voltage will cross VB, okay, let the VB is 5 volt again, for example, and here it is 6 volt. So the diode will be off. The diode is off. So just consider the diode is open. Okay, so output will be Vin. Simply the output will be Vin. So this is the situation for positive cycle. We have two different cases. And for negative cycle, okay, place the diode. For negative cycle, for whole negative cycle, you will get this minus and this one is plus. So the diode is always off. Check, the diode is always off because this N side will get the negative potential and this side is connected to positive. Okay, so diode is always on means the V0 will be same as VB. This. Let's plot the graph. Okay. So as long as this one, okay, this will be VB. As per our analysis, check, V0 is VB. And for second case, when Vin just cross VB, V0 equal to Vin. Okay, so for this part, so that is Vin greater than VB. So V0 equal to Vin, input and output, they are same. It's just a rough sketch, so it will be same as this. And again, for that part, when Vin less than VB, again it will be constant. Okay. And for entire negative cycle, output and input, V0 will be VB. V0 will be VB. So this is the output. And this is the input. Okay. So this is all about the shunt clipper or parallel clipper. So similarly, you can go for series clipper. In series clipper, see, the diode is connected in series. But in shunt clipper, the diode was connected here in the parallel, but here the diode is connected in series. So one thing is clear that in series clipper, when the diode is on, the input and output, they are connected. See, when the diode is on, the input will be output. And when the diode is off, the circuit will be open. Okay, when the diode is off, this part will be open and V0 will be simply 0. Okay. Now see, for example, this one, for positive cycle, the diode will be on. Okay, for positive cycle, the diode will be on. And when the diode is on, simply V0 will be Vin. And for negative cycle, this diode will be off. So hence it is open and V0 will be 0. Similarly, if you change the polarity of this, the things will be just opposite. Now, similar to your parallel clipper, you can add one bias voltage here, okay, which is connected in series with this diode. The operation will be same. Now check. The diode will be on when the input voltage, that is the voltage at this point, is greater than the VB. Again, for example, we consider VB equal to 5 volt. So the N side of diode connected to 5. So you need to apply a voltage here at this point, which is at least greater than 5 volt. So when your input voltage is less than 5 volt, so when V less than VB, the diode will be off and simply output 0. And when V greater than VB, the diode will be on. And when the diode is on, the output, see, output, it is basically the Vin, the combination of Vin and this VB, we can easily calculate by applying KVL. So we have a situation when the diode is on. So let us see. When the diode is on, the diode is replaced by short circuit. Check here. Previously, the diode was connected here. When the diode is on, the diode is replaced by short circuit and this. Now, if we apply KVL in this equation, the statement will be V in, this voltage will be equal to this voltage plus this voltage. So V in equal to VB plus V0. Or simply V0 equal to V in minus VB. So when the diode is on, the output you will get, so that is basically V in minus of VB. Okay. So in series clipper, the output, here you need to apply the KVL to find out the output. So the output you will get here, the V in minus VB when the diode is on. And when the diode is off, simply the output is 0. We already analyzed that part. When V in less than VB, diode off, simply the output is 0. And when the diode is on, the output will be, it will follow the input signal waveform, but this voltage amplitude will be V in minus VB. This is. Okay. Similarly, you can go for another one example here, that the diode polarity and the battery voltage connected in the opposite way. So you can check for positive cycle. For positive cycle, this one will be plus, this minus. So the diode will be off, and of course the V0 will be 0. Now for negative cycle, so this will be negative, this is plus. Now see, we have a situation in negative cycle. In the negative cycle, when the V in is greater than minus VB, that means as long as this point voltage greater than this point voltage, okay, so of course the diode will be off. The N side voltage greater than P side voltage, the diode will be off. Suppose for negative cycle, this is -1 and VB is -5. So diode will be off. So diode will be on when the voltage at this point, that is input voltage, is just below -5. Okay, that means for this condition, when V in is just less than minus VB, then the diode will be on, otherwise the diode will be off. And when the diode is on, again, you can draw the equivalent circuit. Okay. When the diode is on, so you can just replace the diode by short circuit here, then put the battery here, and this, the circuit became like this. Now apply KVL, so V in equal to VB plus V0. So V0 equal to V in minus VB. Okay. So you can calculate. So the process is same. When the diode is on, so you have to draw the circuit and you have to calculate what will be the output voltage. And similarly, you can sketch the result. So depending upon the polarity of a diode and polarity of a supply voltage, you will get a different output. So those are the example of series clipper along with bias voltage. Okay. So that's all about clipper circuit.